So here on number 26, so it's adding fractions. This first one, 8/11 plus -3/11. We just get to add straight across because they have a common denominator. So just as a reminder, this is like a late elementary school type problem, I do believe. Common denominator, just add them. So the second one here, x/6 plus 2/6, same thing. They have a common denominator. X and 2 aren't like terms. So this one just becomes x plus 2/6. This last one is a little bit trickier because it's 1/3 plus 2/5. So again, as a reminder, we know we need a common denominator here. And so with 3 and 5, the common denominator would be 15. So you may have done this different ways. You would multiply this first fraction by 5/5. And you would multiply this second fraction by 3/3. Remember, I'm really just multiplying by 1 and by 1. They just look really funny, especially that one. Multiplying by 1 doesn't change it. So this first fraction then becomes 5/15 plus the second fraction becomes 6/15. And when we end up with 11/15 there. So again, if they don't have a common denominator, we have to make one, which is going to be important for kind of what we're doing today. Or we're going to have to do that, I should say. All right, so here on number 27, it says examine each expression below. For each one, use your understanding of adding fractions to add the algebraic expressions and simplify your final expression if possible. So A is 2x over 2x squared plus x minus 21 plus 7 over 2x squared plus x minus 21. So these have a common denominator. So since these two have a common denominator, we're able to just add straight across, or our numerators, I should say. So our denominator stays 2x squared plus x minus 21, and our numerator becomes 2x plus 7. All right, so we added them, and then it says simplify if possible. So as of now, we can't simplify anything. This 2x and this 2x squared, those don't simplify at all. We can only simplify if we have a factor in the bottom that's the same as the top. So we need to try to factor this denominator, 2x squared plus x minus 21. So we get negative 42x squared. X is on bottom, so this is going to be 7x and negative 6x. So 2x squared and negative 6x have a greatest common factor of 2x, which makes this left side x. That's a 7, and that's a negative 3. So my denominator then factors into x minus 3 times 2x plus 7. So by factoring it, we have a 2x plus 7 in our numerator and a 2x plus 7 in our denominator. So part A simplifies to 1 over x minus 3. B is 5x divided by x squared minus 2x minus 3 minus 15 divided by x squared minus 2x minus 3. So again, common denominator on this problem. It's a subtraction between our two expressions. So 5x minus 15 divided by x squared minus 2x minus 3. So same thing, we need to factor it, our denominator, to see if it'll simplify with anything in our numerator. I'm going to do it up here just since I have a little bit more space. And I'm going to make it not so big. So you get x squared negative 3, negative 3x squared negative 2x, which makes the sides of my diamonds negative 3x and x. X, negative 3 and 1. So my denominator here on part B simplifies to x plus 1 times x minus 3. Looking here, though, we have 5x minus 15. That doesn't simplify. Neither of these are 5x minus 15. But this 5x minus 15 can also be factored because there's a greatest common factor there. So it's like doing the distributive property backwards. We know 5 goes into 5x and 15. So if I factor out of 5, inside my parentheses would be x minus 3. 5 times x is 5x. 5 times negative 3 is negative 15. X minus 3's, they cancel out. Remember, when they cancel out, they make a big 1. It divides by itself. So I get 5 divided by x plus 1. Yeah. Okay, part C, we have 3x plus 9. God bless you. God bless you. Divided by, God bless you, 8x squared minus 50 minus x plus 4 divided by 8x squared minus 50. So another common denominator here. So this one, I'm just going to kind of write it out the long way to show you all the steps along the way. So this numerator becomes 3x plus 9 minus, and then I'm going to put that x plus 4 in parentheses just to kind of show you we have to subtract that whole thing. My denominator is 8x squared minus 50. And some of you, when you're doing these, you're going to skip that step I just wrote, and that's okay. I kind of expect you to, especially once you kind of pick up on this and remind yourself how you do these. So this becomes 3x plus 9 minus x minus 4, because you have to distribute that negative to everything. So this really becomes 2x plus 5 divided by 8x squared minus 50. Again, some of you are going to go straight from this first kind of original problem to here. You're going to say, okay, 3x minus x is 2x, and then 9 minus 4 is 5. Make sure you distribute that negative. Even if this were a negative, then you still distribute it to become a positive. Okay, so we've combined our like terms. Now we need to try to simplify this. So our numerator cannot be factored at all. 2x plus 5 is just 2x plus 5. There's no like terms there. Our denominator, if we look at it, we should be able to see that we have a greatest common factor. 8 and 50 are both divisible by 2. So I'm going to factor out a 2 for my first step down there. So if I factor out a 2 in my parentheses, I get 4x squared minus 25. God bless you. You always want to get out your greatest common factor first if you can, if there is one. So my denominator factors into 2 times 4x squared minus 25. Well, 4x squared minus 25 is a quadratic. It has an x squared. It has no middle term. That b value is missing, which when your b value is missing, you should ask yourself, is this a difference of squares? So the square root of 4 is 2. The square root of 25 is 5. So yes, it is. Again, you can factor it with a box and diamond. It's going to be a little bit more work, but you'll still get the right answer. So if it takes you a little bit more work to get the right answer, that's fine. That 2 stays in front, but 4x squared minus 25 factors into 2x plus 5 times 2x minus 5. The square root of 4x squared is 2x, and the square root of 25 is 5. So you get 1 plus and 1 minus. 2x plus 5 simplify. So we have 1 divided by 2 times 2x minus 5, which is equivalent to 1 over 4x minus 10. I would accept either answer here. If this were kind of a multiple choice test, either your chapter test here, SATs, some other kind of test, you should be able to recognize that these are the same. Again, I don't care what way you leave it in your denominator. Just recognize that those are the exact same thing. And then part D, last one with a common denominator, we have x squared plus 5x minus 2 divided by 3x squared plus 2x minus 8 plus 2x squared minus 3x minus 6 divided by 3x squared plus 2x minus 8. So common denominator here makes it more straightforward, and it's addition, which makes it a little bit easier. No need to worry about distributing. So x squared plus 2x squared, we get 3x squared. 5x minus 3x is 2x. Negative 2 plus negative 6 is negative 8. And here you see we have 3x squared plus 2x minus 8 divided by 3x squared plus 2x minus 8. So this is just equal to 1 because it's the same thing in the numerator and the denominator. All right, questions on any of those when they have a common denominator? Because on problem 28, we're going to be working with problems that don't have a common denominator. All right, so A here is x divided by 3x plus 1 plus 2x squared minus 2 divided by x minus 5 times 3x plus 1. Hi. Okay, so we don't have a common denominator, but one of the factors is the same. There's a 3x plus 1 in both of our denominators. So this first expression doesn't have an x minus 5. So we need to put an x minus 5 in this first fraction. So we need to multiply it by x minus 5 times x minus 5. So by doing that, I have x times x minus 5 divided by x minus 5 times 3x plus 1 plus 2x squared minus 2 divided by x minus 5 times 3x plus 1. So again, I'm kind of showing you every little step right now. So I multiplied this first fraction by x minus 5 over x minus 5. Again, this is just 1. So now I have a common denominator. So my next step, I'll be able to combine these. So it'll be x minus 5 and 3x plus 1 in my denominator. This numerator right here, x times x minus 5, we know is the same as x squared minus 5x. So if I'm adding these, x squared minus 5x and 2x squared minus 2, so I have x squared plus 2x squared, I get 3x squared minus 5x minus 2. So my denominator is factored. I need to factor my numerator. So I have 3x squared negative 2. So that's negative 6x squared negative 5x, which makes the sides of my diamond negative 6x and 1x, or just x. Negative 6 times 1 is negative 6. Negative 6 plus 1 is negative 5. So here, 3x squared and negative 6x, I get 3x times x up here, negative 2 and 1. So this problem, my numerator, now that I factored it, is 3x plus 1 times x minus 2, and my denominator stays the same, x minus 5 times 3x plus 1. Notice I never multiplied my denominator together because then I would have just had to factor it. Typically on these problems, you end up wanting to factor so that you're able to simplify. So here I can see I have a 3x plus 1 in my numerator and my denominator. So we get x minus 2 divided by x minus 5. Hi. All right. Go to the back for part B. So it's 9 minus 3x divided by x plus 3 times x minus 3 plus 2x divided by x plus 3. Okay, so we can see that both denominators have an x plus 3, so we need to get an x minus 3 in the second fraction. So we need to multiply by x minus 3 divided by x minus 3. Remember, we're multiplying by 1, so we're not changing our problem at all. So this becomes 9 minus 3x over x plus 3 times x minus 3 plus, if I distribute on top, I'm going to have 2x squared minus 6x. Again, 2x times x and 2x times negative 3. My denominator is x plus 3 times x minus 3. So it's addition, so I don't have to worry about any distributing. So I get 2x squared minus 9x plus 9 divided by x plus 3 times x minus 3. Hi. Yeah, we're almost done. All right, so our denominator again is factored, so we need to factor our numerator so that we can hopefully get something to simplify. So 2x squared and 9. So 18x squared negative 9x. So two numbers that multiply to positive 18 but have a sum of negative 9. That's going to be negative 6x and negative 3x. Yeah. Oh, you can man. All right, so this becomes 2x, x, negative 3, and negative 3. So 2x minus 3 times x minus 3 divided by x plus 3 times x minus 3. Oh. My x minus 3's simplify, they divide out to be a big 1. So I get 2x minus 3 times x plus 3. Or sorry, divided by x plus 3. Oh, yeah? All right, and then last problem, 29. So it says Astacia wants to learn more about excluded values. So remember, excluded values are what x is not allowed to be. So on part A, explain to Astacia why x cannot be 4 in the expression x plus 2 divided by x minus 4. So we want to know why x can't be 4. So we have x plus 2 divided by x minus 4. So x doesn't equal 4 because, I'll share that paper in just a second. So x doesn't equal 4 because if x equals 4, then we have 4 plus 2 divided by 4 minus 4, which is 6 divided by 0, and you can't divide by 0. So that's why x isn't allowed to be 4. Remember, to determine your excluded values, you just set your denominator equal to 0. Part B on 29 says to find the excluded values in problem 28. So this is part B. So we want to know, again, without the red, that was our original problem there. We need to know what x isn't allowed to be. So this first set of parentheses, x plus 3, we know x can't be negative 3 because then it becomes 0. And the second one, x minus 3, we can't have positive 3. 3 minus 3 would be 0. So here, x doesn't equal negative 3 and x doesn't equal 3. Those are our two excluded values in this problem. You don't look at your answer, you look at your original problem. What would have made the denominator 0? So again, if I plug in negative 3, I have 0 here. If I plug in positive 3, I have 0 here. It doesn't matter what the other one is because our denominator would be 0. And then going back to part A here, so we want to know what makes our denominator 0. So x plus 5, or sorry, x minus 5, well, that just means x can't be 5 because that would be 5 minus 5 would be 0. We need to know what makes 3x plus 1 0. So you could just kind of do that off to the side. If you're not sure, 3x plus 1 equals 0. Sorry, I can't. And solve that. So you're also going to get that x doesn't equal negative 1/3 because you're going to get negative 1/3 when you solve that. You want to know what happened, what makes this equal to 0, and that's what x isn't allowed to be. So x can't be 5 or negative 1/3 for part A. Questions on that? No? Okay, that is all we have for today. So a little bit shorter. If factoring is easy for you, this shouldn't be too bad. Hopefully, if you have questions, I will stick around. Otherwise, you guys are free to go, and I will see you tomorrow at 10 a.m. Hi. Hi. Your hands are cold. What do you see? What do you see?